bosons. That's a very that's a very particle physics standard model particle physics way of calling the different particle families. If you're thinking cosmology and you just want to club together all of the ordinary matter and just call pretty much all the protons and neutrons by some clubbed name, some group name, then people say baryons. So we mentioned how in the Big Bang nucleosynthesis, the baryons did have a role to play, and as things started to cool down, we started to make a little bit of hydrogen. In fact, that is what the Big Bang made. Pretty much as far as matter goes, because back then was a very radiation-dominated universe. We also talked about the evolution of the universe in our cosmology lives, which I encourage you to find and follow and listen to or watch as you please under the live tab, because we actually cover a lot of the early universe and evolution of the universe and kind of what happens in what era of the universe in those cosmology lives. Because we've spent a lot of time talking about astronomy, which is sort of more specific events, phenomena, and objects in the sky, including galactic events and galactic objects, as well as extragalactic objects. But then cosmology is really the more larger scale field that goes into the details of the universe and how to think about the universe, and also the evolution of the universe from the start to where we are now. And we talked about how the universe has changed, just like we change, just like human beings change over time. And we think of things in terms of maybe decades. It's maybe of value to think about our astronomy, galaxy, the cosmology, universe in terms of giga years. So thinking about which things sort of happened in which billionth year. Given that the universe is only about 14 billion years old, you might want to think about, okay, in this giga year, this happened, and in the beginning, sort of first giga year, what might have happened. And in fact, we have something very exciting from the first several 100,000 years of the universe, which is really very early, which is the cosmic microwave background photons, of course. So basically, I mentioned about the giga years to give you some idea for the timelines, because we shouldn't expect the universe to change on the timeline of us human beings, right? In fact, another little reference for you here is that Earth and our solar system is around 4 giga years, right? It's around a little bit over 4 billion years old. And the sun the sun is a relatively new star. It has, the sun and our planets were formed out of a nebula, a gas cloud, condensating at some point to make our solar system. And ever since, the sun, of course, has gone around the galactic center. So just like we orbit the sun, the Earth, I'll start with the moon. The moon orbits Earth, the Earth orbits the sun, and our sun orbits our galactic center. We have a supermassive black hole at the galactic center called Sagittarius A star. We have also mentioned quite a bit about this black hole and the galactic center. So the sun, you might wonder, in its lifetime of just a little bit more than a few giga years, how many times has it completed revolutions around our galactic center? And that number is only about 20 times. So the sun is not quite a teenager anymore in terms of our galaxy, because 19 would have been a teenager. It's 20, so it's a young adult in terms of stars. So quite young, quite new. And of course, there was no sun, as an example, when the universe was getting started. There were no stars when the universe was getting started. The first stars what we call very metal poor. Yes, sun's old enough to party. Yes, the sun is not old enough to drink yet, in the US at least. Maybe the sun can drink in the Caribbean islands, US Virgin Islands, where you can drink at 18. It's a territory of the United States. So with different laws. So so the sun is quite new.